Hello guys, so today we are solving this problem, minimum limit of balls in a bag. So let's understand what is the problem is. So you are given an integer array nums where ith bag contains the nums I balls. Just like simply let's say this is our nums array, then this is like number of balls. So this guy has number 2 balls, 4 balls, 8 balls, 2 balls. These are kind of number of balls in a bag on ith bag. Okay. Then we are given a max ops. One variable is given us that maximum number of operation we can put is 4. Okay, so let's continue here. So we are given an integer called max operation. So there is a one operation we can do on the balls. Okay, so what that operation is, take any bag of balls. Okay, out of this array we can take any bag. All of these are bag, right? 0 1 2 3, they are bags. So we can pick any bag, and what we can do is we can basically divide that bag's balls into the 2 bag. Okay, for example, let's say suppose we are picking this guy. Let's say I have picked bag, this one, the location at here 0, the one which is sitting at the next one. I'm taking that bag, so this has value 4. So I can split it into the 2 bags in the sense this can make 3 and 1, this can make 2 and 2, like that. Okay, we can divide in this way. So 2 bags can accommodate the balls like this, either 3 and 1 or 2 or 2 or whatever combination is possible. Okay, so we are supposed this kind of text. So the operation is we can pick a ball out of this all those bags and make them 2 bags with these combination, either 3 1 or 2 2 or whatever it could be, right? So we have to split the number of balls in 2 bags with whatever combination. So let's continue. So they have given same example. For example, we have a 5 balls bag, then we can make 1 and 4 or 2 and 3, it's up to us. Okay, so that is the one what we can do. Now what we have to do is, your penalty is the maximum number of balls in a bag. So what does it mean is, like if we do these many operations, max operation times, okay, so we have to make our operation in such a way that the maximum value should be minimum. For example, here there are 4 operations we can take, right? So what we can do is, after doing these 4 operations of this kind of split, our maximum value in this resultant num should be minimum. We have to do the operation in such a way that the maximum value should be, there could be multiple maximum. Then we have to pick the value, we have to do the operation in such a way that our max value should be minimum possible out of all combination. So what we can do here is, like this is, let me complete the indexes of this. So what we can do here, so one operation what we can do, so let's say we are taking this guy, the bag sitting at index 2. So what we can do here is, it would become like this 2 4 and it's up to us. Let's say I'm making 4 and 4 of this, right? So 2 bags are making, so 1 bag would be coming extra here, 2 4 4 and 2. Okay, so we have done in this way. So 1 operation is done. So how many operations remaining here? We still have 3 operations because we are done with 1. Now we can again pick one of them, right? So let's say I'm picking another 4 out of it. So it would become like something like this. Let's say I'm picking this guy. So what it would become? It would become 2 and 2 and 2, right? And these guys are 4 4 and 2, right? 4 4 and 2. Now how many operations left? We have left two more operations. Now we have to again split it. So let's say we are picking this guy, right? Because we need to minimize the maximum value. That is why I'm picking these greatest guys. So we would have remaining things would be as it is. This would be 2 2 2, and I have picked one of the bag. Let's say I'm picking this time this guy. So I can make this guy as 2 and 2, right? So 2 and 2 I'm just making, and this would be 4 and this is 2 right now. So we have one more operation left, right? So we have one more operation. So what I will do is, I can take this time this guy, right? So what it would be happening, finally it would be like this. All other would be like this, 2 2 2 2 2, right? All of them would be become 2 2 2 2 2, and the 2 for this guy I am splitting in 2 and 2, right? So what is the maximum now? Now maximum is the 2 only, right? Maximum is the 2 only. So this 2 should be my answer. Now I could have gone for 3 and 1 as well, but in that case I would be getting 3 as the maximum, right? So I want the minimum value of the maximum after doing these many operations. So this is what we have to do. Okay, now the main concern is how to do it. Sometimes it looks like we can do it with the some max heap or min heap, right? We can do with the max heap, it looks like that, but we don't have a grid here. We just cannot go always with the divide by 2. For example, let's say I'm taking another example. This was one of the favorite example, but our case is not always to divide by 2 and we will get the best answer. No, so that grid would not work here. So we should realize them with, take your pen and paper, do some research over it. Then you will visualize that, okay, divide by 2 would not help. For example, let's say I have the array like this, 9, right? So if I do it, let's say, and max operation is equal to 3, let's say this time, 3 operations. Then what I will do is, let's say if I divide by 2, it would become what? It would become 4 and 5, right? So we can accommodate in this way, that 4 and 5. If it is odd number, we can accommodate divide by 2 plus 1. So 4 and 5 is the split. So we did one operation, right? Now we can do one more operation. Let's say this operation is 2. Okay. Now we can do one more operation. So if I do this, will in this way we will go 4 and we will pick this guy 5, right? So we can do it 3 and 2, right? So in 2 operations, after doing these 2 operations, what is the max here? We are getting 4. We were going with the grid of divide by 2, and if it is odd number, then 4 and 5, like this, difference of 1, right? We went in this grid, so we got 4. But what if I wouldn't go in this way? I'm not going by divide by 2 strategy. Then it would be, this might give me a different answer. So for example, instead of going divide by 2, what if I do 9 with the 3 and 6, right? So I can split this 9 as 3 and 6, right, in one operation. Now in next operation, I can pick this guy and I can make this 3 and this guy also 3 and this guy also 3, right? So now our value is in 2 operations. The maximum value is becoming now minimum. It was 4 when we were doing divide by 2, but here it is 3, right? So B cannot go in the grid of divide by 2. Then what should be the solution? Okay, our max heap would not work here, right? So what to do that? So what if I say we can use binary search? Now some of you might have a question that where is the binary search possibility? We are not sorting anything. How can I call it that we can solve it by binary search, right? So we can have a possibility here. Like as we know, this is 2, 4, 8, 2, right? So the maximum values should be coming starting from 1 till the maximum of 8, like 8 is the maximum, right? So we know that only one of them should be the answer of us, correct? So with this intuition, we have a one possibility. Let me just remove these extra stuff and then we will talk about our approach. First of all, I would be telling you that how would anybody will get this kind of intuition that we have to go in a binary search way, right? So I'll tell you one thing. You guys know the minimum value in a bag we can put 1, correct? And maximum value we can put in a bag is 8 here. If we talk about here 8, right? So 1 and 8 would be our range, right? So it would be like either we can have 1, 2, 3, 4, 5, 6, 7 up to 8, right? So it is starting from 1 till the whatever is the maximum available in this array, right? So between them only we have to pick one of the answer. So we got one intuition. Now you know these guys are sorted, right? If they are sorted, that means we can pick in a binary search way, correct? So what we will do is we will get the minimum, the mid of them. Okay, so whatever 8 plus 1 divided by 2, it would give us 4, right? So this value, right? So we will check that whether is it possible. So why we are doing is, like, we have to look for out of this range, we have to put this array and we have to check whether can we put any one of these value which will satisfy with these number of operations. Okay, so how we will do it? Let's say in this case our mid would become right plus left divided by 2. So my left is here, this guy. My left is the very first one and right is this guy. Okay, so my mid would be obviously 1 plus 8 divided by 2. Okay, So it would be anyway 4. 1 plus 8 divided by 2. So my mid would be 4. Now what I am gonna do with this mid is I want to check that can I distribute all the balls with these operations, these many operations. Can I distribute all the balls which should go either equal to or less than 4? Can I do that? I want to check this thing with these many operations. Okay, so how to do that? So let's say we are picking this guy 2. So this bag has only 2 things, right? So there is no possibility of further splitting it because our mid itself is 4, correct? So we are not wasting our any operation here, correct? So this would be kind of a 0 thing. Now come to here 4. So can we split it into further? No, in one operation we have to split it into 2 bags, right? But this is just 4 and our mid is also 4. So there is no operation to waste here, correct? Now come to this guy 8. So can we split it in such a way that this guy can accommodate less than or equal to 4? Yes, we can do. We can make it 4 and 4, right? This is the only operation. If we go into 5 and 3, then our violation, right? Because 5 is greater than 4. So 5 and 3 split would not be taken here. So with this help, we can say that for 4 we can we have taken one operation here, right? So after doing this operation, we are able to make that 4 and 4, which is a valid combination. So we spent one operation here. Now we will come to this guy 2, right? So 2 is already like smaller than 4, so we don't have any possibility to further split. So you guys can see here that just one operation, we can make this entire array in such a way that every value have the up to 4 value max, right? So we can make it 2, 4, 4, 4, 2, correct? So now we know that 4 can be one answer, but we are looking for the smallest answer. So if we are looking for the smallest answer, we have to look for the further smaller value. Okay, we just cannot stop. So what to do for further smaller? So I want the further smaller value. That means I should decrease my right, correct? Because if I am able to distribute 4 itself, that means I can also distribute some more smaller values, correct? So what I will do is I will decrease this right. So this right I would become 3. So basically I would make my right in this case, if we can do that, then I will make my right equal to what? My right would become mid minus 1. Okay, this is what we do in our normal binary search, right? So I will do it mid minus 1. So then we would coming to this guy. Our right is now here. Our right is now indicating this guy 3. So now what would be our new mid? Our new mid would be 3 plus 1 divided by 2, right? So this is becoming 2 here. Okay, so now we got the new mid as 2. Now we have to look that can we distribute within these number of operations, can we distribute everything up to 2, correct? So we will come here. So let me remove these things and we will again evaluate for value 2. So just let me remove it. See here, now our mid is 2. So we will evaluate for value 2. Okay. So see here, this is 2 only, right? They are equal. So no possibility of further split, right? So we don't want to split based our operations. So far our operations are 4 only. So we are at 4 now. So 4 we can split, right? We can split into 2 and 2. So we can split in 3 and 1 as well, but 2 and 2 is the valid because 3 would be greater than mid. So we don't want. So 2 and 2 we can split it. So we spent, now we have 3 operations because one operation is taken here. Okay, let me tick it green. Okay, so I will tick it green that yeah, one operation is taken here. Now we'll coming to 8. Okay, so when it is 8, we can in one operation we can split into 4 and 4, right? So one operation is gone here. So now how many operations we left? We left only 2 operations. Okay, now we can further split these guys, right? So in one operation we can then make them 2 and 2. Similarly, so now we have left only one operation because we took another operation here. So one operation here, one operation here, and one operation here. So we are left with one more operation. So we have this 4. So we can split this guy also in 2 and 2, right? So we are done now. All the operations are gone. So now we will further go for this guy. So this is 2 only, which is already like less than or equal to 2 only. So in this case, what is happening? This 2 is the value which was smaller than the earlier value, which we can still distribute. So we can say that so far we got another answer 2. So 2 is also a value which can be distributed within the 4. Now who knows, we will go further smaller, right? And if we go for the further smaller, again we will make our right equal to mid minus 1. So our right would be what? Our right would be become mid minus 1. So 2 minus 1, right? So it would be 2 minus 1. So it would be right would be 1 now. Now our right is also 1 and our left is also 1. So what would be the mid? Mid also becoming 1, right? So we are coming to the mid equal to 1. So we will look. So can we split it 2? Yes, in one operation we can split this guy as 1 and 1. Okay, fine. So one operation is gone here. Then we will come to this 4. So 4, yeah, we can split into this guy 2 and 2 in one operation. And further here one more operation here and one more operation is here. So we already took 3 operations is already gone. So we are left with 1 operation only. Now we will come to 8. So for 8 to make 1, we have to first make 4 and 4, right? So we don't have any more operations. Already we used 4. So we just cannot take this answer as 1. Okay. So finally what we will come after getting this answer. So this time we are not able to distribute with these many operations. So if we are not able to distribute with these operations for mid equal to 1, that means we have to increase our left side. Okay, so our left would be, in this case, what it would become? Our left would become mid plus 1. So mid plus 1 equal to 1 plus 1, which is 2. Now you can see left is 2 and right is 1. Okay, which is violation of the binary search, because we are using the binary search. So now we will come out of our loop and we are having the answer, valid answer, which is 2 in this case. So now you guys would have got why did we use the binary search here. So this is the way we can do. Now I will tell you one more thing here, that for every time we were picking the mid value here and we were checking that whether is it possible to achieve for all of them with the maximum value less than or equal to this mid. So we were doing this, I have explained it, but how to write this thing in a code. So I will explain that as well. Right, we will taking the mid here and we will checking whether is it possible to distribute here. So we will write a method called is possible. Okay, that is possible method I would be explaining. Whatever I have just done, I will write it in terms of code as well. So let me explain, because that is a key part of this question. So let me do that as well. As we know that every time we were achieving the mid from that series, right, we were getting the mid and then we were calling this based upon this mid. We were checking whether it is possible to distribute the values of this array in such a way that it is not going beyond the value mid, right? So we have to write a method for that. So what we can do is basically whatever this mid value we are getting, we will pass that method. Let's say I'm calling this method as is possible. Okay, so if this is possible, what we are passing here, we are passing this variable mid, right? We are passing this variable mid, we are passing this num array. So let's say this is our num array we are passing, and what all things we are also passing the number of max operations, right? This would be the signature of our method. So what we are supposed to do is we have to check whether with this mid value can we do redistribute using the operations, so that any value would not be the greater than this mid, it should be less than or equal to. So what we were doing is, let's say we are going to every value of this array nums, right? So let's say we have mid equal to, let's say somehow we are getting 5, suppose. Okay, so what will happen here? What if we are coming at this location? This is basically smaller, right? So anyway this would give us 0. This is 4, this is also give 0, because we don't want any operation, these are already smaller. But see here, this is 8, right? So in this case what will happen, we can split it 8 like this, 5 and 3, right? We can split it in 5 and 3, we can also split it in 4 and 4, right? Both are valid because maximum value here going is 5, not beyond that, right? So in one operation we are able to do that, right? If let's say it was 15, In that case, what would happen? In that case, it would be like one operation. So 5, one operation would have taken 5 and 10, but 10 is maximum, then we need another operation. So this will make 5 and 5. So how many operations we took? For value 15, let's say instead of 8, it was 15, then it would have taken 2 operations. One is to make it 5 and 10, and then one more to make 10 is equal to 5 and 5. So it took total 2 operations, right? When we have the mid equal to 5. Now consider that we have this mid equal, this value instead of 15, let's say it was 17. In that case, how many operations would have happened? So in that case, we will, let's say 17. So for 17, in one operation, what we can do? We can make 1 is 5 and this is 12, right? So in one operation, we got split into 5 and 12. Now 12 is greater, so we still need to call this method. So 12, so in one operation, we can make it 5 and 7, right? So total 2 operations are already done, but 7 is greater. So we have to still make it further. So we can make it like 3 and 4, right? So total 3 operations it took. So you remember in case of 15, we took 2 operations, but in case of 17, we are taking 3 operations, correct? So if it is completely being divided, like 15 was divided by 5, right? So if it is completely being divided, we got only 2 operations, but if we are getting some extra fraction, it is taking 3 operations. So what would be the generic answer to find? So the generic answer would be, if we go for a ceiling function, okay, so whatever we are dividing, if we are getting ceiling function, so let me go for ceiling function, you know, right? If we, let's say, if we are calling ceiling function on 15 divided by 3, okay, so it will give us directly 3 only, because it is completely being divisible. So it will give 3 only. But if I give this, you can say 5, yeah, not 3. So 15 divided by 5. So it is giving us directly 3. Okay. But if I do this 15 equal to, instead of 15, if I put 17, so 17 divided by 5, then ceiling function, what it will give? It will give the greater integer, because it is give me 3 point something, right? 3.15, something like that. Then what would be the ceiling function? Ceiling function would be giving us 4, right? It will go to the upper nearest integer. So 4 minus 1, if I do ceiling function of this minus 1, it will give me the correct answer. So 17 divided by 5, it is coming 3 point something. Okay, so it would be given 3.2 something. Then ceiling function give me 4. So 4 minus 1. So whatever ceiling function answer, minus 1 will give us the correct answer every time. You can check in example of 15. Let's say I'm taking 1, 5. Okay, so in this case, what would be the ceiling function? Because it is completely dividing, so 3.0, right? So it will give 3 only. So 3 minus 1. So we got 2 only, right? Our answer was 2 for the 15 and our answer was 3 for the 17. So now we can, in generic way, we can say one thing, that on every, on any index of this array, nums array, we have multiple values and we want to check that how many operations we can make it, which would be distribute the value into terms of mid, which is less than or up to mid only. So we can directly say for any value in this array, we can do whatever is the nums I, okay, whatever is at that nums I, divide by mid, okay, divide by mid, and the ceiling function of it, okay, we will wrap this thing in a ceiling function, CEIL, ceiling function minus 1. This will always give us the correct answer, that how many operations would be required to nullify the one of the value here. Okay, so in this way we can do it. Okay, so what we can do is, like we will write that this method is possible, and here we are passing the mid value. This is our nums array and this is our maximum options. So we will check for every value here. Every time we call it, we will go for every value and we will find that how many operation. So ceiling of nums I divided by mid minus 1. This will give us that how many operations are required at ith location. So let's say here requires n1. Okay, then this guy required n2. So all of them might be whatever sum it is there. we will sum them up, that how many operations are required to make it compliance of greater than or less than or equal to mid. So let's say this is sum is coming something like t. T is the total number of operations. So if this t total number of operation is smaller than or equal to max operation, which is allowed number of operations, if it is like this, if t is less than or equal to this max ops, then we can say that yes, we can distribute it evenly. We can distribute with the mid value up to max value. Okay. And if it is greater, that means we are taking more operations, then it would be false. So this is what we are doing using this function. We will check for every mid, and binary part I have already explained. So let's go to the overall coding of it. So let me explain it. What is my code doing for this? So I have solved it already. So I'll open it. Yeah, it's there. So you guys can see here. I have just, this is binary part. So let's, before going to this, we are going to the can distribute part. Okay. So see here, we are passing the nums array and the maximum number of operation and the max val. You can call it the way which we are calling the mid val. Okay. So see here, we are traversing through this array and we are doing the total number of operations. So we are going for every value and we are making the ceiling of the x divided by whatever the value we are passing. We are passing the mid here, -1. So this will give us the total operation throughout this array. Now these total operations, if they are less than or equal to allowed number of operations, which is max operations, that means it is true that we can distribute. Otherwise it would be false. So this utility method would be used in our main function. So see here, we are having left equal to 1 and right equal to 0. So left we are starting with 1 and right would be basically the max value inside function. So here I am replacing this right value with whatever is the maximum value inside array, right? So see here, I just put answer equal to 0. Now see here, we are going in this binary way, that while left is less than or equal to right, we are calculating this mid value. And see here, as soon as we calculated this mid value, we are calling this function can distribute function. Okay. So this can distribute function would be called here and it will check for all the values that can be used with this max value under these number of operations. Can we get a valid number of operations so that we can distribute it up to this max value throughout this array. So if it is returning true, that means with this mid value we can find an answer. But we are looking for the further smaller answer. So what we are doing, we are updating right equal to mid -1 because we got the answer for mid. So we are reducing this right equal to mid -1. Otherwise, if we are not able to distribute it, we have to increase the value of mid. That is why we are making left equal to mid +1. Because if values are higher, then operations would be lesser. If values are smaller, to get that smaller value, we need more operations from a higher value, right? We distribute, then further distribute. So in this way, when we will doing this, so finally we would have, see here, I am updating here. Finally, we are returning our left. Left would be having our minimum max value. So let me run it, though I have already submitted it. So yeah, it is already submitted, it's not a problem. So guys, the important thing is how to come for this kind of intuition. So to get this kind of intuitions, we have a list of problems which are based upon this kind of binary search operations. So we have the important thing is like we were not getting any grid position, but we came to know that the value should be somewhere between the left and the maximum value inside the nums array. Then we did a 1 to up to max value. So we are having this sorted list, and based upon that we are checking. Thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.